All right, next one is number 15. It says a health study reported that in one country, systolic blood pressure readings have a mean of 118 and standard deviation of 17. A reading above 140 is considered to be high blood pressure. Complete parts A through D below. Okay, so what is a z-score for a blood pressure reading of 140? Looks like you found that z-score is 1.29. Let's double check it. So I'm going to go ahead and open up a blank Word doc so that I can type the z-score formula. Z-score equals x minus the mean divided by the standard deviation, right? Where are you, symbol? Right there. And we're given all these numbers. X is, what's the number that we're interested in? X is 140. 140 minus the mean blood pressure is 118, and then the standard deviation is 17. So on your calculator, type this in, 140 minus 118, and then divide that by 17. The z-score comes out to be 1.29. And is this how they wanted you to round it? Round to 2 decimal places as needed. Great job! So you got the right z-score of 1.29. That's great. So now what? Let's go and read part B, C, and D. B. If systolic blood pressure in that country has a normal distribution, what proportion of the population suffers from high blood pressure? Okay, so let's open up the, what do you need? The My Math Lab. You know where I'm going. I'm going to StatCrunch to use my normal calculator. We're looking for probability in a normal distribution, right? We can use a standard normal table, but I think it's faster to do it this way. So I'm going to StatCrunch to open up normal calculator. It never works. Oh, it worked the first time. Awesome. All right, so I'm going to go to Stat, Calculators, and click on Normal. And I'm going to type in, you got the z-score, so we can use the standard normal and just keep it with 0 and 1 and find the number of people who has a high blood pressure higher than 1.29 of a z-score and get the z-score, the probability to be 0.0985, 0.0985. Let me go and see where that was. So you can type that in. I wonder if I can type this here. Edit. You just sent me a picture of it, so I don't know if I can put it here. Or I use your z-score because you found it, but we can also use the original number, but that should give us the same exact answer. So the answer will be 0.0985 rounded to 4 decimal places. I think that's what they wanted, 4 decimal places. Or you can go ahead and use the original numbers they gave you. The mean was what? 118. Standard deviation was 17. And they said people who have a blood pressure reading higher than 140 is considered to be high blood pressure, to have that. So if you find that, you get the same exact 0.09. Is it slightly different? Okay, it came out slightly different. How would you explain that? It's because, remember, when you found that z-score, you rounded it, right? So you rounded that z-score to 2 decimal places, so it came out a little bit different. The first number that we got was, you know what, let me go ahead and copy this down so that I can just compare these numbers over here. They shouldn't be too far off. That's the number using the regular mean, the mean and the standard deviation, the original. But if we decided to convert these into a standard normal score, 1.29, we got the probability to be, let me just copy right there. You see how they're slightly different, right? So if I were you, since they ask you to find z-score, I would use it and go with the number that we got from using the z-score, 0.098, because otherwise, why would they ask you to find the z-score? But both answers are correct. And to be honest, the answer that we got using 118 and 17 is more accurate because z-score was rounded in the middle of a problem, right? So that's how you do B. Let's look at C. What proportion of the population has systolic blood pressure in the range from 100 to 140? Now, I'm going to go ahead and click on between, and we know that the mean is given as 118 and the standard deviation is 17. And they said find the probability, or how did they word this? They said a proportion of systolic blood pressure between 100 and 140, right? So type in 100 for the lower bound and 140 for the upper bound and click compute. Ta-da! So about 75.73%, or if they're asking for proportion, you can give them 0.7573 will be the answer. But that's how you can use the between, this part right here, between, what's this? Okay, between function or calculator on StatCrunch to find that proportion, okay? All right, let's look at the very last one. D, find the 90th percentile of blood pressure reading. So what does that mean, 90th percentile? That means we want to find the blood pressure reading that has 90% of the say data before it, right? So or below it. So this is what I'm going to do. I'm going to use that same calculator, but just backward. What I want is I want the probability to the left of this point to be 90. And in a standard, I'm going to keep it as 118 for mean and standard deviation 17. Get rid of that blank and change that to less than or equal to. Why we're doing that? Because percentile is looking at how much you have before that point. And what I want is I want a z-score that will have 0.90, and 0.90 is 90% in decimal, 0.90 to the left of that very point. And then if I leave this one blank, because that's where the answer will pop up, if I hit compute, I'll get that blood pressure to be 139.78. So we can say that is the 90th percentile blood pressure, 139.78. And however they wanted you to round, round to the nearest whole number as needed. So you would type in 140. You will type in 140. If you want to check it, you can type in 140 there, and what we should see when we compute, the probability or the proportion should be very close to 0.90. It is, right? But if I go down to 139, 89, that's 89th percentile. So I will go with 140 for part D there, okay? So notice how we can use that StatCrunch normal calculator to answer a lot of these normal distribution probability calculation problems, right? So remember that.